Okay, so a lot happened this week. Like, a lot. New video editing. AI you can talk to instead of clicking through timelines. A camera tool that finally lets you actually direct a shot instead of hoping for the best. A voice cloner that's honestly a little unsettling. And one release that has nothing to do with any of that and might genuinely matter more than everything else on this list combined. Let's just get into it. JoyAI-Video-Edit, editing video as it plays, not after. Let's start with the one that should genuinely surprise you. It comes from JD.com's open source research team, and it's called JoyAI-Video-Edit. The pitch sounds simple. Describe an edit in plain language, and it happens to your video. But the engineering underneath it is what actually makes this worth 15 minutes of your attention. Here's the difference from every video editor that came before it. Traditional video editing, even AI-assisted editing, works on a complete file. You upload a finished clip, the model processes the whole thing, and eventually spits out a result. JoyAI-Video-Edit throws that model out entirely. It processes frames the moment they arrive, whether that's an uploaded file streaming in or an actual live camera feed. It never needs to know how long the video is going to be, and critically, it never looks ahead at future frames to make a decision about the current one. Every edit decision is made causally, based only on what's already happened. Why does that distinction matter practically? Because it's what allows this to run on a genuine live stream, not just a file you drop in and wait on. In the released benchmarks, the full pipeline sustains just over 30 frames per second at 720p resolution end-to-end, meaning the editing keeps pace with the video playing in real time without falling behind and building up lag. The range of edits it handles is broad. Full style transfer, turning a normal video into a watercolor look. Local edits, changing just one object or person while leaving everything else untouched. Background replacement, subject removal, where a deleted person's space gets filled back in convincingly. Clothing and style swaps. Reference-guided editing, where you can point it at a reference image and ask it to apply that look. In one published example, an entire scene, people, hairstyles, and interior gets transformed into a British aristocratic castle setting, all from a single instruction. In another, multiple dogs in a video simultaneously get turned white, get party hats added, and one dog's sunglasses shift to hot pink, with every change staying consistent across every frame of motion, not flickering or drifting as the video plays. Architecturally, this is a 16 billion parameter system built from 3 components working together. A large multimodal language model that reads and interprets your natural language instruction, a specialized causal video encoder, decoder that processes frames one at a time without needing the future, and a diffusion transformer that actually generates the edited output. JD's own team benchmarked it directly against the current leading streaming video editors, models called Sana Streaming, Live Edit, and Xmax X2.0, and reported it leading across global style transfer, local object editing, and even automated subtitle editing tasks. One detail worth flagging. Honestly, those are the developer's own comparative benchmarks, not an independent third parties, so treat the specific margin of victory with appropriate skepticism, even though the underlying speed numbers and architecture are independently verifiable from the technical report itself. It's released under Apache 2.0, meaning commercial use is fully permitted, and JD has specifically optimized the deployment for consumer-grade hardware, citing the RTX 5090 as a target GPU. That's still a genuinely high-end consumer card. Not something everyone has sitting in their desktop, but it's a meaningful step down from requiring actual data center hardware. The team has also indicated a stronger version is already in development, with a specific focus on reference image-guided editing, so this is very much a first release in an active pipeline, not a finished, static product. Copy, finally, real control over the camera. Here's a problem anyone using AI video generation has run into. You get a great shot, and the camera does whatever it wants. A team from the University of Hong Kong, HKUST, and Tencent's ARC lab just built a genuinely clever fix called SKPE. The core idea is different from how most camera control tools have approached this. Instead of bolting on a separate module that tries to steer the camera after the fact, SCOP-E builds camera control directly into the model's coordinate system. Every piece of the video, every token, gets assigned its camera ray, essentially its exact line of sight, as a second coordinate alongside its normal position. That ray is fixed by the camera path you specify, so the geometry itself resolves what the camera should be seeing rather than the model guessing. And the results, shown directly on their own project page, cover real, specific cinematography. A pullback combined with a rise, a push and sweep, a slow S-curve reveal, a wide orbit, a crane arc, a straight dolly in or out. Multiple examples show the exact same starting scene, browsed under 6 completely different camera paths side by side, so you can see the geometry is actually driving the result, not just adding random variation between takes. One capability worth calling out specifically: they demonstrate what they call revisit consistency. The camera turns 90 degrees, moves through a doorway, and returns to where it started, and the previously seen parts of the scene stay anchored in place instead of drifting or regenerating differently the second time around. That's a genuinely hard problem in AI video, keeping a scene spatially consistent when the camera revisits it, and their explanation for why it works is elegant. Since the outbound and return paths reuse the exact same ray coordinates, the model is addressing the same points in space from the same geometric position both times, not relying on some separate memory system trying to remember what it painted there before. Technically, this is a lightweight addition to existing pre-trained video models, not a model built from scratch. It adds under 0.1% new parameters to a model that's already trained, and, by their own reported numbers, it reduces camera rotation error by 29% and improves overall video fidelity by 43% at their larger 14 billion parameter scale. It works across both 5 billion and 14 billion parameter model sizes. The code, model weights, and a working live demo are all public, with the full research paper available on RxIve for anyone who wants to check the methodology themselves rather than just take a company's word for the numbers. LTX 2.5, a new foundation model built to be fast enough to own. This one's positioned differently than a lot of video models you'll see. LTX isn't just shipping a one-off release. They're calling LTX 2.5 a foundation model, meaning it's specifically built as a base you can fine-tune on your own footage and deploy on your own infrastructure, not just a fixed tool you prompt and accept whatever comes out. Let's start with the speed claim, because it's the headline and it's backed by real published numbers, not marketing language. Self-hosted on their own hardware, LTX 2.5 generates a 10-second 720p clip in 620p. That's genuinely faster than real-time, meaning it renders the video quicker than the video itself would take to play. Through their API, that same generation takes about 24 seconds, still dramatically faster than the competition. According to LTX's own published benchmark chart, comparable models take far longer for the same task. Minimax H3 needs 180 seconds for a 10-second clip. Kling 3Do Pro needs nearly 400 seconds. Even Google's Veo 3.1 comes in at 70 seconds. If those numbers hold up under independent testing, LTX 2.5 isn't just faster. It's in a completely different speed category from most of its closed competitors. On visual quality, they're also reporting real, specific numbers rather than vague claims. Using an automated scoring system measuring visible glitches, blotches, and melted or smeared textures across 98 test prompts, LTX 2.5 Pro scored 0.28 artifacts per clip, the lowest, meaning cleanest, score among the 10 models they tested, edging out Minimax at 0.46 and Google's Veo 3.1 at 120. Worth flagging clearly, this is LTX's own benchmark, run on their own methodology, and they describe it themselves as preliminary, expected to evolve as evaluation continues. That's a meaningfully more honest disclosure than most companies give you, but it's still a self-reported number, not an independent third-party test, so treat it as a real data point worth knowing, not a settled external verdict. What actually changed in this version? Technically, a new video decoder aimed specifically at cleaner motion, Genuine native multi-shot generation that keeps character, environment, lighting, and voice consistent across cuts within one continuous generation, and a completely new text understanding system built on a 12 billion parameter Gemma 4 encoder paired with a custom prompt enhancer, which is what's behind its improved ability to follow complex instructions from shorter, simpler prompts. It also added automatic duration prediction, so the model decides how long a clip needs to be for the requested action rather than you guessing a fixed length up front, and it now supports native 4K HDR output plus a professional RAW workflow for teams doing real color grading and finishing work downstream. On Access, this is where LTX 2.5 makes a genuinely different set of choices than most closed competitors. The weights are fully open and downloadable, with no mandatory branding requirement, meaning you don't have to display "made with LTX," the way some competing tools legally require you to credit them. It runs on any GPU with a minimum of 16 gigabytes of VRAM, which is a real, attainable bar for a lot of serious hobbyists, not just enterprise teams. And it's free to use, including commercially, for anyone under 10 million in annual revenue. If your business or channel crosses that threshold, licensing terms shift. But for the vast majority of people watching this, that's not a wall you'll hit anytime soon. If you'd rather not manage local hardware at all, API pricing is billed per second of generated video, 9 cents at 720p, 15 cents at 1080p, 19 cents at 2K, and 37 cents at 4K. Index TTS 2.5. Text-to-speech technology has quietly crossed a threshold that most people outside the space haven't fully clocked yet, and Index TTS 2.5 is a clear, concrete example of exactly how far it's gone. It needs only a few seconds of a reference voice as input. From that small sample, it can generate that same voice saying anything you type, matching tone, texture, and cadence closely enough that in direct side-by-side listening, telling the generated version apart from the real speaker gets genuinely difficult. It's not limited to flat, neutral narration either, which is where a lot of earlier TTS tools fell apart. Index TTS 2.5 demonstrably handles real emotional range. One published example generates a genuinely angry, emotionally charged delivery, with actual vocal tension and intensity in the performance, not the generic, flattened sounds mad quality that older, less capable tools tend to produce when pushed toward emotion.
What is a surprise?
Surprises just...
Translate this for me!
It also works fluently across multiple languages, and one of its most immediately useful capabilities is cross-language dubbing, taking a scene originally recorded in one language and generating a version in a completely different language, using the same cloned voice throughout, timed and delivered naturally rather than sounding mistimed or robotically translated. Why does this matter beyond being a neat demo? Professional dubbing and voiceover work has traditionally required hiring separate voice talent for every language a project needs to reach, which is expensive and slow, and it scales linearly with every new market you want to enter. A tool that clones a single reference voice once and can then generate natural-sounding speech in that same voice across multiple languages removes a real, significant cost and turnaround barrier for any creator or studio working at genuine scale. It's fully open-sourced, and the entire model comes in at roughly 5.5 gigabytes, small enough to run comfortably on hardware most people already own, not something that requires a specialized workstation. Minimax Music 3. Full songs, under 3 gigabytes. Last week, the same team behind this tool released what's currently considered the best open-source video model available. This week, they followed it up with what's being called the best open-source music generator to date, and the story here isn't primarily about audio quality, even though that quality is genuinely strong. It's about size. Minimax Music 3 takes a text prompt describing genre, tempo, key, and specific instrumentation combined with a mood or overall vibe description, and pairs that with actual lyrics that include structural tags marking the intro, verse, chorus, and bridge sections. From that combination, it generates a fully arranged, professionally produced sounding track. Not a rough sketch or a loop, but something that sounds like a finished song. Here's what actually sets this release apart from the rest of the music generation field. The full model comes in under 10 gigabytes, and a further compressed version drops all the way down to just 2.5 gigabytes. That's small enough to run on genuinely low-end GPUs, hardware that couldn't realistically handle almost anything else in this category of AI tools at all. That's a meaningful accessibility shift, not a marginal technical footnote. A huge amount of AI tool coverage quietly assumes the viewer has access to serious, expensive hardware, and most people simply don't have that. A capable, full-featured music generator that fits comfortably in 2.5 gigabytes puts genuine creative capability into the hands of people running years-old, budget graphics cards, not just people who've invested in the newest high-end setups. For independent creators who need background music, intro themes, or complete original songs without a production budget or the licensing headaches of stock music libraries, this is one of the more genuinely accessible tools to land all year. SL2T, Google DeepMind's sign language model, and the quietest release of the week. Not everything this week was chasing a benchmark chart, a speed record, or a price war. This last one is worth genuinely slowing down for because it's solving a problem that's been almost entirely unaddressed in consumer technology until now. Google DeepMind shipped a model called SL2T, short for Sign Language to Text, and it's shipping inside two real consumer products, Gboard and Live Transcribe, launching on the new Pixel 11. It reads sign language captured live through the phone's camera and converts it directly into written text in real time as the conversation happens. A deaf or hard-of-hearing user can sign to search the web, draft a message or document, or ask Google's Gemini a question anywhere they'd normally have needed to type. Inside Live Transcribe specifically, a deaf user can sign their side of a conversation instead of typing back and forth with a hearing person, which fundamentally changes the pace and naturalness of that interaction. The scale of what this model was trained on is worth understanding, because it's exactly what makes the result credible rather than just another incremental accessibility feature nobody actually uses. It trained on more than 100,000 hours of data spanning over 50 distinct sign languages, roughly a quarter of that specifically in American Sign Language, the language it's launching with first. Google frames this correctly as a genuinely hard problem and not simply a variant of speech to text. Sign languages aren't spoken language mapped onto hand gestures. They're independent languages with their own grammar, their own vocabulary, and meaning that gets conveyed simultaneously through hand shape, movement, facial expression, and body positioning all at once, not sequentially the way spoken words are. Google has also been unusually transparent about the model's real limitations, which is worth respecting rather than glossing over. Accuracy degrades in low light or harsh backlighting. It struggles when clothing reduces contrast against the signer's hands and face. It tracks only the largest subject in frame and can't currently handle multiple simultaneous signers. Performance drops at extreme camera angles. And critically, the system keeps the signer in the loop throughout. Both apps show a text preview before anything gets sent so the user can review and correct errors. And in Live Transcribe, the deaf user specifically controls when translated text becomes visible to the other person in the conversation. Worldwide, more than 70 million deaf and hard-of-hearing people use over 200 distinct sign languages, and there's genuinely no existing consumer product performing this exact function at comparable scale. This isn't a head-to-head replacement for something else on the market. It's a first real entrant into an almost entirely unaddressed category. It ships at no additional cost on the Pixel 11, with Google explicitly stating that more devices and additional sign languages beyond ASL are already active work, not just a hypothetical roadmap promise. That's 6 things that actually shipped this week. Not vaporware, not a teaser, all real, all linked below if you want to go try any of them yourself. Honestly, the sign language one stuck with me the most out of all of this. If you want more of these, stick around. I'll keep doing this every week.